Dear students of medical and non-medical stream, 11th class and their respected teachers, first of all, I welcome you all on my YouTube channel, Physics Concepts and Motivational Talks. इसे शायर ने कहा है कि जरूरी नहीं हर वक्त लबों पे खुदा का नाम आए, वो लम्हा भी इबादत होता है जब इंसान किसी के काम आए, जब इंसान किसी के काम आए। सो 10-15 मिनट इस वीडियो च ਤੁਹਾਡੇ ਨਾਮ ਤੁਹਾਡੇ ਲਈ ਫਿਜ਼ਿਕਸ ਲੈਸਨ ਲੈ ਕੇ ਆਇਆ। ਮੈਨੂੰ ਪੂਰੀ ਉਮੀਦ ਹੈ ਤੁਸੀਂ ਇਹਨੂੰ ਜ਼ਰੂਰ ਅਟੈਂਡ ਕਰੋਗੇ ਔਰ ਓਪਨ ਮਾਈਂਡ ਹੋ ਕੇ ਅਟੈਂਡ ਕਰੋਗੇ ਔਰ ਮੈਨੂੰ ਉਮੀਦ ਹੈ ਕਿ ਤੁਹਾਨੂੰ ਸਾਰਾ ਸਮਝ ਵੀ ਆਊ। ਸੋ let us start today's topic, dimensional formula. In first video of measurements, I have explained about fundamental units, derived units, basic systems of measurements, SI system, CDS system, advantage of SI system over CDS system, dimensional equation, everything. Basic things I have already discussed in my first video. You can watch first video before watching this video. Now, in first video we have explained M, L and T as the fundamental units of mass, length and time, and M, L and T, the mass, length and time, are known as fundamental physical quantities. Now, how to derive various dimensional formula of physical quantities and to know their units from their dimensional formula. So suppose first is area. We know area is length into breadth, means L1 into L1, that is L square within square bracket. So L square is a dimensional formula for area. It means if length is measured in meter, area will be measured in meter square. So knowing units of length, we can find units of area. Second, volume. Volume by definition, length into breadth into height, that is L1 into L1 into L1, that is L cube. So L cube is a unit dimensional formula of volume. So if length is measured in meter, then units of volume will be meter cube. Then velocity. Velocity is defined as rate of change of displacement. Displacement means distance covered. L1 time t1, or it will be L1 t minus 1. So knowing units of length and time, we can know the units of velocity. If length is in meter, time in second, so units of velocity will be meter per second. Very easy. Then acceleration. It is defined as rate of change of velocity, that is velocity upon time. So velocity we have obtained L1 t minus 1 over time t1, it will be L1 t minus 2. So L1 t minus 2 within the square bracket gives dimensional formula of acceleration. So if length is in meter, time in second, so units of acceleration will be meter per second square. Similarly, force. F is equal to ma. This is Newton's second law of motion. Or m1, acceleration we have proved L1 t minus 2. So dimensional formula of force will be m1 L1 t minus 2. So again, knowing units of m, l and t, we can find units of force. Then pressure. Pressure is defined as force per unit area. So force we have obtained m1 L1 t minus 2 over L2. It will be m1 L minus 1 t minus 2. So m1 L minus 1 t minus 2 is the dimensional formula of pressure. Means you have to simply remember first 5 dimensional formula and you can obtain so many dimensional formula of all other physical quantities. For example, momentum. Momentum is mass into velocity. Again, mass m1, velocity we have calculated L1 t minus 1. So it will be m1 L1 t minus 1 is the dimensional formula of momentum. Then work. Work is force in distance. Force m1 L1 t minus 2 into one more L1. That is, it is m1 L2 t minus 2. Potential energy formula is mgh. So So it will be m1 L1 t minus 2 acceleration due to gravity into height L1. So it will be m1 L2 t minus 2. Similarly, kinetic energy, it is half mv square. Now half has no units. Mass m1, velocity L1 t minus 1 whole square. So it will be m1 L2 t minus 2. So we can see work, potential energy and kinetic energy. In other words, work and energy have same dimensional formula as well as the same units. Then we come to power. Power is defined as rate of doing work. Now work done is m1 L2 t minus 2 upon time t1, it will be m1 L2 t minus 3. So m1 L2 t minus 3 is the dimensional formula of power. Then angle. Angle is defined as ratio of arc to radius of circle. So arc is also length L1, radius is length, so it will be m0 L0 t0. It means angle is dimensionless. Even it has units, but in this system angle comes out to be dimensionless. Strain. Now strain is defined as either change in length over original length or change in volume over original volume, means length upon length or volume upon volume, means L cube upon L cube. So it will be m0 L0 t0. Strain is also a dimensionless quantity. It means angle and strain both are dimensionless. Then impulse. Impulse is defined as force into time. Force m1 L1 t minus 2 into time t1. So it will be m1 L1 t minus 1. Then frequency, reciprocal of time period nu, it is t minus 1. So if units of time is second, so units of frequency will be second inverse or per second. Then there is Planck's constant. There are some constants that we use in next chapters. So Planck's constant, small h. So according to Planck theory of radiations, energy is given by E is equal to h nu, where h is Planck's constant, E is energy, nu is the frequency. So therefore h comes out to be E upon nu. So at this stage you can remember this formula of Planck's constant, E upon nu. Energy m1 L2 t minus 2 over frequency t minus 1. So it comes out to be m1 L2 t minus 1. Then gravitational constant. We have studied Newton law of gravitation and gravitation in lower classes also. So which is given by every body in this universe attracts every other body, and the force of attraction is given by F is equal to G m1 m2 upon r square. So from that formula G comes out to be F r square upon m1 m2. The force is m1 L1 t minus 2. R square means L square. Mass m1 m1. 1 m1 cancels. So it comes out to be m1 L3 t minus 2. So m1 L3 t minus 2 is the dimensional formula of gravitational constant. You need not to remember this. No need. So if you want this dimensional formula, you can derive from this formula, because this formula is very familiar. So this is Planck's constant and this is gravitational constant. Then we come to stress. Stress is force upon area. That is pressure. It has units of pressure same, m1 L minus 1 t minus 2, that we have calculated, m1 L minus 1 t minus 2. So stress and pressure have same units, same dimensions. Density, it is defined as mass per unit volume. Mass m1, volume L3, ऊपर जाके minus L3, so it will be m1 L minus 3. It means if units of mass is kg, length is meter, so units of density will be kg per meter cube. So very simple. Then wavelength, length of wave, simply L, unit of meter or centimeter. Relative density, ratio of density of substance to density of water. So it gives m0 L0 t0. It means relative density is the ratio of the same two quantities, is dimensionless. Angular momentum is the moment of linear momentum. In rotatory motion you will study angular momentum in detail. So L is equal to mvr. This is the formula for angular momentum. So mass, velocity L1 t minus 1 and distance is L1. So it comes out to be m1 L2 t minus 1. As you can see, angular momentum and Planck's constant h both are same dimensional formula, means same units. Now, moment of inertia, it is defined as mass into distance square. Mass m1, distance L2, so it is m1 L2. So if unit of mass is kg, distance is meter, it will be kg meter square. Then there is surface tension, property of water when its surface is free and at rest or any other liquid. So sigma, it is defined as force per unit length. That we will study in chapter of properties of matter, liquids. So it comes out to be m1 L1 T minus 2 over L1, that will be m1 L0 T minus 2. So we can find dimensional formula of surface tension. Then all elastic constants that we study in properties of matter, that is Young's modulus, bulk modulus, coefficient of rigidity. So all have dimensions of pressure. Because they have dimensions of pressure, the definition is just similar to pressure. m1 L minus 1 T minus 2. Then there is a coefficient of viscosity that we study in solids also. So its dimensional formula is m1 L minus 1 T minus 1. You can remember for the time being, and when we study this coefficient of viscosity in chapter of liquid properties of matter, then we'll derive this dimensional formula in that chapter. So this is all about dimensional formula. These are the main important physical quantities whose dimensional formula I have calculated, and you can also practice by writing on your notebook, and no need to remember all these units. Now, on the basis of this dimensional formula or dimensional analysis, we can divide all the physical quantities into four categories. Number one, dimensional variable physical quantities, means those which have dimensions and are variable, that is, their value is not fixed. For example, velocity, force, acceleration, all momentum, all are dimensional variable physical quantities, means they have dimensions and their value is not fixed, they may have any value. Then non-dimensional variable physical quantities like angle, strain, they have no dimensions, they are non-dimensional, but they can have any value, they are variable. So second type is non-dimensional variable physical quantities. Third is dimensional constant physical quantities. Dimensional constant physical quantities means those which have dimensions and are constants, that is, their values are fixed. For example, gravitational constant G and Planck's constant, their value is fixed, they are constants, but they have dimensions. And fourth one is non-dimensional constant physical quantities, like all numbers, integers 1, 2, 3, 9, value of pi is 22/7, it has no units, value of e, small e, base of log, so value is 2.718. So all have fixed values, but they have no units. That's why they are called non-dimensional constant physical quantities. So this is all about dimensional formula and the types of applications, types of physical quantities on the basis of dimensional formula. In the next video, I will discuss the applications of dimension analysis. That is, using method of dimensions, we can check, number one, the accuracy of a given relation. These are the applications. There are so many uses of this dimension analysis. That's why we are studying all these dimensional formula. So first application is, we can check the accuracy of the given relation, whether the given relation is correct or not, without knowing the fundamental laws of physics. We can derive an expression for a given relation. So we will discuss all these application detail in the next video. So for today, just remember all the dimensional formulas. Not remember, just you have to practice. So when you will practice, and you will remember most of the dimensional formula. So you have to remember only 5 4. So these are used everywhere. So knowing 4 dimensional formula, area, volume, velocity, acceleration, force, we can obtain all the dimensional formula. So this is all about today's topic, dimensional formula and its applications and types of physical quantities on the basis of dimensional formula. So be happy, enjoy yourself, God bless you, and just chill